Welcome to another edition of the Sim Racing Garage. I'm Barry Rowland. In this edition, we'll be reviewing the M2 Motion platform from the guys at DOFReality. At around $900, this is the least expensive seat mover solution I could find available from a retail vendor. So, how much motion goodness can you wring out of an entry-level priced motion platform? Time to put it through the SRG's review process and find out. So, let's get to it. So now for a closer look at this M2 moving unit. Seat mover. Right, so let's talk about the top of the frame. First, this is a 6 mil thick piece of metal here, steel, and it looks like it's got a tube, a solid tube going in between these two L brackets here, or the L forms that we see here. And that's definitely some substantial strength here, I'm sure. Now, we've got 4 sets of holes here, and 4 holes in each one of those sets. And of course, that's so you can mount your seat or your rails in your seat or whatever you're going to do. And I took some measurements here. Center to center, we have at the extreme holes, one, in other words, the furthest hole from the back, and this is the back of the unit, to the furthest hole in the front. And that comes out to 325 millimeters. Now, crossways, we've got a lot more. It's like, 410 millimeters on the crossways, 410 going that way. Now we have 15 millimeter center spacing on each one of these holes. So that's information you can use when you decide what kind of seat mount you're going to need. Of course, we could always fabricate something to go across here and accommodate something else. Like my Sparco is 340 millimeters. I would have to put some aluminum plate probably across here and all the way across here, then drill some holes closer together and then mount it. But I have another seat that's going to fit directly to this, which is very cool. Now, this whole plate here is attached to this bracket here. And there's a universal joint. You can actually see the cap of it here. And it's a normal universal joint that you would normally see. It has the needle bearings in it, and it makes it so it can move. You can see it moving here. It's not turned on, but it is moving a little bit. And that's from the lash in these levers, and we'll talk about that in a minute. And so the bottom frame is actually 1.5 millimeter steel. But you can see there's a lot of reinforcement going on here in this part of the frame. We've got 2 pieces up here that the motor mounts are being used as a motor mount rather. And then we have another solid tube here. Not solid, but it's hollow, but it's not cut out from the bottom, so it's all the way wrapped around. So that is a tube. And we have 2 tubes obviously welded here and welded across the tube back here. So this lends to me to be and you can feel it, it's a very sturdy unit, even though it's 1.5 millimeter with this many welds and this much attachment going on. It's a pretty firm unit. Now, enough about the steel. Let's talk about how this is working and the motors and the gearboxes here. First off, they're using some rod ends here. We've got a rod end up here that's actually connected to one down here. So that gives us the freedom of the lateral flex or movement that you might need, so it prevents any twisting and binding, which obviously is a good idea. Now, these actual gearboxes, they have a plate on them here, and they call these gearboxes, what were they? NMRV30s. And here's a picture of it, of the actual label, so you guys can see the close-up of the label. Now, I actually went and looked up these gearboxes, and they're actually worm gears. So what that means is the electric motor here is attaching to a shaft that's coming out of here, or it might even be some kind of a coupler in here. It depends on the design. And there's actually a worm gear, and here's a shot of that, showing you what it looks like inside of a worm gear gearbox. As you can see, the worm gear is riding on top of another gear that's actually attached to the shaft that comes out the side. And coming back to our gearbox, this is where the lever is mounted, and of course is attached to the platform up here so everything can move. And you can see there is a little bit of movement in this lever itself, right? And that's the gear lash between the worm gear and the gear that's in there. And I'm not sure if this is good or bad. We'll find out when we're using it. But you got to have some lash in there because your gears will be binding up. But it seems like there's some movement here. I mean, you can judge for yourself what you think about that. You can see how far it's moving. So when the seat is sitting still and unpowered, we will have some movement in the seat, which is typical, though, of a seat mover. The NLV does it, and any seat mover I ever had, my Sim Experience seat mover did it. When it was sitting there, when it was unplugged and unpowered, the thing would just collapse if you didn't watch it. But when it's powered up, it would stop that. So it still had some flex in it. It's just the nature of the beast, I think. Right, so let's move around here. First off, while we're on this side, let's talk about that motor back there. Now, the label's actually under here, and we can't really see it, but I did have a chance to take a shot of it while I was messing around with this and taking things apart and doing what I do here at the SRG. And here's a shot of that. You're looking at the label. It's a Sunrise motor, and it has some other labeling on it. I found online some things that might have been it, but I didn't want to, post you a picture on here of my review unless I knew exactly what it was. We do know this. According to DOFReality, this thing is a 24 Newton meter torque. I'm guessing that's peak torque. And yeah, so that's a pretty powerful motor to be moving the lever there in the seat. So I think that should be enough. And we have actually, the whole platform has a movement of 16 degrees in any plane, in the X or the Y axis. So pitch and roll, obviously. So yeah, that's, again, I don't know much else about the motor, except that I think this unit, you can buy these things. I know you can buy them as a unit with the motor and the gearbox attached, ready to go, with just a shaft sticking out here. And of course, it can be a 12 mil or 11 mil shaft, depending on what your needs are. And yeah, I'm pretty sure that's the way they purchase these, because I saw a lot of that online. If you go look for this kind of stuff, you'll see it right away. Now, let's go back around to the front here. Now, of course, if we're going to be using this to move a seat, we're going to have some way to read the position of this shaft here, right? We got to understand what's going on. And actually, they use these sensors right in here. See this little black sensor here? And we got another one over here. And here's a close-up of that sensor, and you can see the number on it here. And these are 1904s, and I really couldn't get clear on the designation between that, but what I do know that this is a position sensor, and it is a Hall effect, so it's a magnet type position sensor. It's not like a potentiometer, a pot or a potentiometer is what I meant to say. And it's not like that. So it's a magnetic in there, so it should have a very long life cycle and be very accurate with the magnetic Hall type of sensor that they're using here. So I like that. I like that they've used that. And I think these things are like $20 a piece just for these little sensors. When I was looking around, I was looking at prices too. So that's how we're going to find out where the position of this is and let the motor know, and let the controller in the box that we'll see later on know what's going on. And how all that gets done, how do we get the power and the data out, is these two cables in the back, as you may have noticed. And they've got this loom type of wrap around it. So we've got some pretty thick wires here. I'm pretty sure that's for the power and the ground. But we've also got, let's go ahead and just bring one of these out of here. So this is what it looks like. We have, and this is going to plug into the controller box, and we'll see that when we get there. And we have 3 of these wires here. Now, of course, this bigger one's probably going to be all the power that this motor needs, or supplying the motor the power. And this one here is going to be the data. So that's the one that's actually wired into the sensor. There we go. It's a better picture of it. And it's, it's just a female 3-pin type deal. And it's got a nice screw connector that will go, and of course it's got the male connector over there on the controller box. We have 2 of these, obviously, 2 motors, and they've actually gone to the lengths of color coding it for us. So the brown one is one motor and this black one is the other. So when we go over to, and you see the actual box, you'll see that they have color coded plugs on them too, so you can't get this wrong. At least I hope you can't get it wrong. Most people will get it right, I'm sure, especially being like this, being color coded. So yeah, what else do we want to talk about here? Really not a lot to talk about besides what we've done so far. With the motor, what kind of drive we have, the worm gear, and how it's connected. So it looks pretty simple to this point anyway. And of course, not most, but all of the controlling action is going to be happening in the controller box. And so what we'll do is go over to the controller box next, and yeah, maybe we'll take a peek inside of that thing and see how everything is wired up. So now we can take a closer look at the controller box. This is where all the electronics are, obviously, and it's a nice looking box actually. It's got the DOFReality logo silk screened on there, and you can see it says to DOF motion platform. And we have the power connectors for the motors, and if you saw the closer look of the platform itself, you would have seen that they are color coded brown and black so that you don't mix them up when you're plugging them in. And we also have a 1 and a 2 silk screened on here for the data connections. We also have the mains switch over here, a USB, and on the top, we've got a couple of cooling fans. And again, this is all powder coated black. On the back, we've got the actual mains connector. We also have this DC, it looks like to me a DC pin type connector. And I'm not sure what that's for. I don't know what the reason behind that is, but anyway, there it is. If we look on the bottom, we can actually start seeing a little bit more what's going on. And you can see we have two switches here for 115 volt or 220 volt. And these are obviously the power supplies. And we see, obviously, we can see some wires here, but I'm sure there's a PCB board or something going on in here for the controllers. And what we'll do next is go ahead and obviously take a look inside and see what's going on. We get 2 screws on each side on the back. It's pretty easy. And 3 on the sides here on each side. So it's going to be pretty easy to take these off. Anything else? We do have some nice rubbery feet here on the bottom. And they're kind of not squishy, I would say, but they're kind of rubbery, so they will bend a little bit, which is good for dampening. So if you have there's some vibrations coming in through your floor or wherever you have this sitting, then those vibrations should be dampened pretty well with those kind of feet on there. Right, so that's the closer look on the outside, and what we'll do is do our look inside next. Now we have the cover off, and we can take a look inside of this controller box. First, we'll look at the top of the box. And you can see we have 2 fans in here. And these are 2 80mm computer fans. And with the labels pointing in like this, normally in a computer fan, that indicates the direction of flow is from where the label is pointing. In other words, it's coming down. This would indicate that we're blowing air into the case. Now, you can reverse the wiring on this and make them go the other way, of course, if you want to. So I'm not sure what the case is here until I put it all back together and it's running. Put that over to the side here. And I like the way that they've actually taken these wires and twisted them up. Very nice cable management touch there. It's a little bit of detail they didn't have to go to, but they did, and I kind of like to see that stuff. Now, speaking of power, they're going over to the power supply here. Now, we have 2 power supplies, one for each motor, and these are very nice units, actually. These are Meanwells, which is the industry standard for if you want a reliable power supply that's not going to break on you too often, then Meanwell is recognized across the industry as the one to get. Now, we have 2 of them here, and I like the way they've mounted them here. They've actually mounted them with metal bands. They've tied them together with these metal plates here. And of course, they're also mounted to the case itself. But this just keeps things a little bit more solid, and I like to see little detail like that. They have their own fan on these power supplies. So we've actually got 4 fans that can run in this box, which I'm not sure as far as what the noise levels would be for that, but we'll see when we get there. And these are LRS 350-24 power supplies, which usually means 350 watt, 24 volt. And it indicates on here that the max current is going to be 14.6 amps. So yeah, pretty good power supplies here for running those 24 Newton meter motors. Now, first off, let's get to this plug on the back here, this DC plug. And when if you guys watched the segment where we were just actually taking a closer look at this case, I wasn't sure what that was for, but as soon as I took the cover off, I knew what it was for. It's for the e-brake. And I wasn't aware at the time that DOFReality has an emergency stop button available. And they do, and here's a shot of it. So you can see for another $50, you can get your emergency stop. And that will plug in here. And what that does is it sends these wires here. They come over to this plug on this little board here. And this little board has a relay on it. And on the other side of the relay, we have the lugs where we actually put the wires in. And you see we have 2 red wires here. One is kind of looping here, but it also loops again under this foam that it's mounted on, and then goes back up here to the mains power switch, right? So that's the switch up there. When that switch is on, that tells this relay to be closed, right? So the relay is closed, and it's sending current over this wire into this power supply, and that wire is also daisy chained into the other power supply, and that's a signal telling the power supplies to switch on and off. That's all that is. So when we have the e-stop on here and we press it down, it sends a signal over here to the board, and it tells the relay to open. And of course, when the relay opens, it breaks the connection between these 2 wires, and we're no longer getting a sense of current on these wires here going to the power supplies. The power supplies kick off. So that's a very simple circuit to get your e-stop to work, and I like simple. It's very efficient, and yeah, simple to work on too. If something went wrong here, easy enough to repair this stuff. You know, get another one and plug it in, and off you go. So I like that, the look of that for sure. Right. Anything else I want to take a look at here? Well, yeah, obviously we're going to get to the electronics part of it, and that would be these boards over here and these boards over here. Now these boards here, you can see, I see the wires going across there from the actual power supplies are going to these drive controllers. Okay, so that's what's actually the drive controller part. So the firmware is telling the drive controller what to do with the motors, or tell the motors what to do. And we've got remember these two plugs up here. These are the data, and of course there's the power. If you look at the data plugs, I'm not sure how well you can see that because these guys are in the way. But yeah, these wires come all the way up here, and they bundle together. There's 6 of them right there going into this top board here. And this board is actually a Sensor Shield version 5.0. And what that is a daughter board or a piggyback board for the Arduino board that they're using to control all this with. So it's being controlled by Arduino board. So it goes into that board. The firmware is interpreting what the signals are saying from the data, and then these wires here are coming out of the board, going over to our drive controllers, right? And these drive controllers are Citon MD13Ss. And here's a picture of them, get a better view of what it looks like. Right, those are DC drive controllers. So these drive controllers get the signaling here, and they're going to tell the motor what to do with the power over there, right? And of course, based on the sensor information they're getting off that Hall sensor that's connected to the gear drive on the motors. If you saw that in the first segment, we were looking at the actual platform, the motion platform. So we got 2 of those, and yeah, again, very simple stuff here. If you need to replace one of these boards, just unplug it. There's another lug back here that we unscrew enough for the wires to slip out, 4 screws out, and put another one in, put it all back together, and you're good to go. Again, I like the way that's going as far as maintenance, as if we needed to fix something. What else we need to know here? Let's show you that little stack there, the Arduino board. You see it's on the bottom there, and of course this board's sitting on top of it. So there it is. Really, like I said, I like what I see here as far as, yeah, simplicity, but effective and getting the job done, and easy enough to fix something if we need to. Right. So I guess that's it for the look inside of the controller box. What we'll do next is get to discussing how we're going to mount the platform itself in my SimLabs P1 rig. So now some considerations on how I want to mount this platform on the P1 rig. Or in this case, probably better to say in the P1 rig. Because what I want to do is set it down in this box that is part of the design of the frame here, and keep it low enough in the box to where the motion platform is not protruding so high that it's going to kick my seat way up. If I mounted it obviously on top here, then that's the actual motion platform is 210 millimeters tall. So yeah, these bars here, these pieces of profile are 4160s, which is 160 millimeter high. So yeah, it would be the seat would be sitting way up here somewhere, which is not very ergonomic, especially considering the way I have it now. So we're going to drop it down inside. Now we got to figure a way to mount it when we do that. But what I think I'm going to do here, and I think this is going to work fine, is the existing bars here that I have this Sparco seat mounted to sit on top. And of course they span the box shape of this rig in that part of the rig. So I can actually take these and put them on the bottom here. So if I mount them on the bottom, that means that the actual bottom of the motion platform is going to be even with the bottom of this rail here. So I'll take 2 of these 90-degree connecting brackets, corner brackets, and put one on each side, on front and rear. And of course we'll have both of these bars up there. Now this actually is will be an easier way to go, I think, because I'll be able to adjust both for width and for where that platform is sitting in this little box of these rails. So I'll be able to better tune it to what I need. And if this is 160 millimeters, this is sitting up, the bar that is actually attached to the sliders under the seat is, let's see, 160 plus, that's about 200 millimeters right there. And if I measure over here where the slider brackets are, and the sliders and the brackets rather, it's about 35 millimeters it looks like. So 35 millimeters. So that's 235 millimeters we have to work with for the seat to be mounted as far as the height goes, and I'll maintain pretty much the same height not exactly the same height because I'm not going to be using this Sparco seat. I'm going to be using a GT Omega RS9 seat. The reason is it's already cut out as far as width goes to fit that platform. And yeah, that way I don't have to fabricate a couple of aluminum brackets that I'm just going to use one time to mount this Sparco seat to it that way. I mean, we could do it that way. If I was going to keep this platform, which I may, then I would do that because this is my favorite seat, and I definitely would not be using an adjustable back seat on this rig. So anyway, if we set this down, remember we're 210 millimeters for the height of that platform. So that gives me 200 here and then 235, another 35 millimeters higher for that platform to sit. But I'm guessing that I can actually set this platform pretty low in here. It's going to be 210 from the bottom lip, so it's going to be right here, the very top of it. So that's almost, it's only 10 millimeters taller than this. I think I'm going to be okay even with that taller seat. The RS9's a taller seat than this bucket is. But we'll find out once we actually get it in here. Plus, we want to make sure that we're not too low to impede the movement of the top of the platform and the roll and the pitch, right? So we got to be careful with that, make sure everything can move freely. So I think that's a pretty good idea, and that's why we're going to do it. So what I'll do is when we come back, I'll have these, obviously I want to take my seat off. I'm going to take these 40 by 40 pieces and I'm going to mount them on the bottom with, again, these two corner brackets on each side. So that's going to be 2, 4, 6, that's going to be 8 corner brackets I'm going to be using. So yeah, when we come back, we'll see how that looks. All right, so we've got our two pieces of 40-40 profile mounted on the bottom like I said I was going to do. And here's another shot of it. You can see on the bottoms here where we actually have two of those corner brackets on each side of that 40 profile. Now, as you might imagine, it's a little bit tedious to get some T-nuts in these bottom rails here, or grooves, slots, whatever you want to call them. And yeah, and then get the bolt in and get everything lined up and actually get your bolt tightened into the bottom. It can be a very, very trying time for you if you don't have a simple tool like this. And this is simply just a mirror, and it lets me get underneath there. I don't know if you guys, how well you guys will see on the camera. Let's see here. Okay, maybe you can see a little bit there. But anyway, you use this mirror here, and you can actually just kind of lay it there, right? So now I can see my bolts and stuff and what my fingers are doing, and that saves you a ton of time and trouble trying to get everything lined up under there when you're blind. So just a little tip there if you ever have to do something like this. Right. So now both of our profiles are in. I've got my 8 millimeter round, roll in rather, T-nuts in here. And the whole pattern on the width of that motion platform is 395 millimeters center to center. So I've got these profiles, just move this a little bit more, right about, yeah, that's about dead on it there. So what I'm going to do now is, now that I have it in the general vicinity, and I'm going to make sure that I get my T-nuts in the general vicinity of, so when I set the whole rig down in here, it's going to be lining up pretty much, at least close enough, that I can actually tap these either way and move my T-nuts either way, front and backwards, and yeah, just get it lined up and then go ahead and run my 8 millimeter bolts in, and then we're done. This thing is mounted. So when we come back, we'll take a look at what it looks like when it's mounted. So now we've got the motion platform. The M2 is now mounted solidly to the P1 rig. And again, that worked out pretty good on those 40 millimeter profiles. Easy enough just to set it in there and bolt it in with some M8 bolts that I had. Had to have, I think they were 35 millimeter to get through the frame and still engage the T-nut. Now, this is very solid as far as the mounting. Now we can see some movement here, but again, this is because of the rod ends. There's some lash in those, and of course there's some movement here in the actual universal joint section of this platform. So yeah, this looks pretty good, I think. And what I'm going to do now is put the seat on. And to mount the seat, obviously we have these 4 holes here, and if you saw the other segment, then you know that I'm going to be using the GT Omega RS9 seat because the width of that seat, the plate, actually the adapter plate that goes under that seat and mounts to the sliders under the seat, is exactly the same as this. So yeah, very easy to get the width right. The only problem was as far as the length of the holes on that mount, they're 200 millimeter. And I had to, and I'm showing you a picture of that here so you can see that they're 200 millimeters apart, which was too short for these holes that are on this bracket here. So what I had to do was mark from here, because I wanted to do it towards the front. The gearboxes go towards the rear on this, and all I had to do was go ahead and mark my 200 millimeter, as you can see here, and then we go ahead and use the punch to mark a better hole, and then it's just a matter of getting the old drill out and drilling our holes. And so now we have it. So all we got to do now is go get the seat, because the bracket's already attached to the seat, and set the seat on here. And I'm going to use some M8 bolts in these new holes right here, and these holes, the first holes in this set of holes on either side. So when we come back, we'll have the seat mounted and see how it all looks. Okay, so now we've got the seat mounted to our M2 motion platform, and yeah, everything bolted up well after we drilled the holes that we needed. And you can see that there is some movement here in this seat, or actually it's in the platform itself, it's not in the seat. And that's typical of these seat mover type of configurations. There's going to be some slack in them when they're not powered up, and we'll see how much slack there is once we have power to it. So yeah, speaking of that, all we have to do now is get everything wired up, and then we're actually going to talk about the software we're going to use to control this DOFReality M2 motion platform. Alright, so we're going to take a look at the application we're going to use to control this platform, and yeah, it's Sim Racing Studio. Some of you guys might be familiar with this if you have their wind simulation solution, which I have, or you have their shaker solution, which is the transducers and the cushions, and they have one that you sit on the seat that you can see here that I'm actually running. And yeah, they have one for the back too. But this is where you can actually control these things. On the telebox tab up here is for the wind power. The next one is shakers, where we set up the configuration for the shakers. Shakers tunings will be next, where we can actually tune the channel volume and the telemetry volume, so we can actually shape this in real time while we're on the track to our preferences as far as what we want to feel in the transducers. Right, now we'll go over to the motion tab. And this is where we're going to actually be looking at the adjustments we can do in real time when we're actually in the game. And I'm going to be running iRacing for this demonstration, but we'll get to that in a minute. We're just going to do some testing right now, and then we'll come back and I'll cut, and then I'll cut back as I'm actually in the car, and we'll do some driving and testing there. So the model here, it has a drop down for whichever model you have, and you can see there's a lot of them represented here. H6, the H2, 3, the P2, P3, P6. Now, right now the 6 is not supported, but that's kind of a placeholder that it will be supported in the future. But the H3, the P3, the H2, and of course, what we're running, the M2, is supported. So we're going to stay with the M2. You can see the status currently is connected, and mode is on. Game is emulator, because the game's not running, but I will go down here and just pick the game you want. And yeah, you can see iRacing's up here. I can actually put that in there because it's already there. And you can see my settings change because I've already been messing around with this and tuning it to get it to do what I want it to do. Right. We've got pitch, roll, yaw, sway, surge, accel, and decel, heave, and traction loss. And we'll talk a little bit about that once we're actually in the game using it. Let's go over to the motion test tab, and that's what this segment's all about. And here we have 3 basic tabs to move. We've got traction loss, roll, and pitch. Well, this particular M2 unit does not have traction loss, so we won't be using that. If I move that, nothing happens. All right. So we're going to actually go in now, and I'm going to superimpose the actual pictures of what's happening when we move this. So I'm going to actually, you can see as I'm moving the pitch up, the seat goes back. You can see the motor's moving. And you can see it's a little bit jerky, a little smoother as you're coming up, because it's pushing my weight up, and my weight is acting as a damper. And you can see it goes all the way, woo, all the way up in an ejection seat angle there. So that's how we're going to test. Again, when you're going back, you can see it's a little bit jerky because it's moving, and then my weight catches up with it. So that's why it looks as jerky as it does. In real use, it's not quite that jerky. And then we go over here and we can actually see the roll. And that, of course, is going to be a right-left roll. And we should see the actuators moving, one going down, one going up. And that's the case as I roll right, almost falling out of my seat. And then we come back and we'll roll to the left. All right, so this is a quick way to actually test the actuators before we get started, or if we want to test them and you could have a problem with something, and this is a good way. Just jump in real quick and you can test the actual movement of it. Right, so that's all there is to it. If I use the traction loss, of course there's nothing going here because we don't have another motor for traction loss. That would be the H3, the P3, or the H6 or P6, because they have that. Right, so yeah, that's about all there is for the motion test. I just want to show you that real quick, and when we come back, I'm going to go ahead and cut over, and we'll be on track then and discuss some more about the motion and tuning we can do over here in the motion tab. So here we are in iRacing in the Ferrari F488, and it's GT3, and we're at Atlanta, the short course. And the reason I chose this course is because of the hills. You can see we've got some hills here, and we are going to disregard those beeps. That's the wheel motor. The wheelbase I'm using is beeping at me because I haven't used it. It's reminding me that it's on. Anyway, so yeah, we're looking up here at the application. Now we are actually in the motion tab, and this is where you'll do all of your adjustments as you go along. And yeah, this is where you'll spend a lot of time as you're riding around the track and you're adjusting things like your pitch, your roll. The sway actually has an effect. We have surge, acceleration, and deceleration. That's for when you're braking, the seat comes up forward, and when you're that's deceleration, and acceleration, obviously the seat should go backwards. There is actually a heave element here. No traction loss, of course, but there is actually a heave has some effect on it too. So we've got these other things interacting as far as, of course, there's no real heave because there's no way that we can go straight up and down, but there is a heave element to this motion. So without further ado, let's get in with these settings that I have and see what happens. Now, you'll watch when I go up and down the hills, the seat will go, as I go up the hill, the seat will tilt back. And when I go down the hill, the seat will tilt forward. So that's supposed to give you the idea of going downhill and uphill, obviously. But also, we want to have the deceleration and acceleration surges when we're actually braking. So going down a hill and braking at the same time can be quite interesting. So let's go ahead and jump in the car here. If I can get it to jump in the car. Let's see, are we not? Let's see if I'm connected here. Okay, so there we go. This is a wireless wheel, so I had to reinitiate the wireless connection up there because I don't even know if I had it on at the beginning, to be honest. But anyway, we should be able to. There we go. See, now that it's all connected, we can get back in the car. I got the car volume down a bit, but let's just go ahead and go out here and see what we've got. And just watch the seat as I go. Of course, I'm turning to the right now, so it's tilting to the left. Going up the hill, you can see it go backwards, and I'm accelerating, so it's kind of a double. Now I'm coming up to the curve, and you can see that I've got the power turned up kind of high here. So to kind of exaggerate the moves here so you guys can see that. And you can see that it's moving around pretty quickly. So it can definitely toss you around and take you for a ride if you want it to. As you can see, I'm still kind of leaned over here until I get the steering wheel back, and then it levels out again. So I didn't get much brake dive there, so I'm going to mess around with, I think, the deceleration slider. See, I'm coming down the hill now and I'm leaning at the same time. So yeah, this is actually turned up higher than I would have it turned up normally, because I want you guys to see that it does have some serious movements or capabilities for movement, even though it's advertised as only a 16-degree movement capabilities. Either way, left or right, up, frontwards and backwards. Pitch, roll. Okay, so we're moving around pretty good here, and what I'm going to do first, you can see as I'm braking, the seat's kind of pushing me forward, as it should when I hit the brakes. And you may hear this, but you can hear the little bit of motor noise here when I'm actually doing things. I don't know how well it's going to actually come out on the audio, but it's really not that bad. First thing I'm going to do here is I'm going to take this power and move it all the way down to about 1/3. Now there's no numbers here on this application, so I wish there was some kind of a number thing so we can know exactly where we were, but that's just not the way this app is working here. So that's about, looks like to be about 1/3 to me. So we actually can turn it down a lot. So let's see what we get now. Usually when it comes to motion systems, less is more. You know, you don't have to have it that radical to still get inputs that feel what the car is doing. So yeah, see, it's not moving that much now. I think a little bit, I went a little bit too low on the power there. Yeah. So yeah, it's not moving much at all now. All right. So let's stop. And, well, I didn't want that to pop up. Okay. So let's go back and move it to about the halfway point. Right about there. And you can save this, but you don't have to until you have all the settings you want. Then you can hit save, because this is real-time changes, and we can just keep doing this, you know, to your heart's content until you dial in exactly what you want. All right, back on the track. Let's see what we got. So now we got some, yeah, now we got some good movement, I think. Actually, this short course is pretty challenging, especially coming over the ridge of this hill here. See how it wants to get sideways on you at speed? So yeah, it's kind of a neat little course, actually. It's got a little bit of everything, I think. Okay, so now I think it's feeling a little bit to where I would like to have it. It's not too radical in the movements, but I can still feel the inputs that the seat's making. As you guys can see, it's still moving pretty good. And yeah. And we're out of control. So that's what happens when I'm thinking about motion instead of driving. All right, here we go. So yeah, I kind of like this. Now, let's say I didn't like this and I wanted to go up on the pitch. Let's just do that as an example. I'm going to slide this. Of course, all this is subjective. You know, everybody's going to want something a little different. And not only that, but different cars will do different things. I'm just going to exaggerate this. I'm going to go up to 3/4 about. Now let's do 2/3. Okay. So 2/3. Now let's get back in and see what that does as far as the pitch going up and down the hills is what that's about. So let's see if that made any difference. Going down the hills. Yeah, I'm definitely getting crunched up against the wheel now. Now we're going up the hill, and it's really laying me back. In fact, it's almost extending my arms out a bit too much. But I'm doing this as an example just to show you guys what it looks like when you have this kind of stuff going on. We're going down the hill now. Go back up the hill, it'll drop away. Come back on the flat, and you can see it rocked back up as I came around the corner there and got back on the flat and got around the corner. It straightened back up. Now we're going back up the hill, and you can see it dropping back again. So yeah, pitch is, it's not, you know, subtle pitch is good, but yeah, this thing I think out of the box tends to overdo that a little bit. So I'm going back on my pitch here. And I'm still not feeling the deceleration that I want. I'm actually going to get pitch out of there. Now roll, I can exaggerate that. Let's go up about half on that. Let's see what that looks like. So we're getting, should be getting more roll than I was before. And yeah, I can feel that. In fact, give it a second here. Let's see what this feels like. Yeah, it's a little bit, I don't know, maybe a little bit much on the roll. And you can see it didn't come out of the roll. I'm still kind of, oh, there it goes. So it came out of the roll right there. So we'll roll again to the left. It came out good on that corner. Yeah, this is, I still feel like I'm leaning to the left a little bit here. I'm straightened out now. Seems it's rolling more to the left than it is to the right. I don't know what it looks like. Going back over here to the right. Too many right-hand turns. So, again, this is going to be something that not everybody likes the same thing. Let me slow this down and see what it does at slow speeds. You can see it at the slower speeds, it doesn't really, yeah, it does, okay. Of course, it shouldn't react as much because I'm at a slower speed anyway. I'm not pulling as many G's when I'm doing this as when I'm really going high speed around a corner. All right, so actually the roll, I'm gonna go back down a little bit on that. Maybe a third total, somewhere around there. All right, so now let's see on the deceleration. Now sway, I can actually put the sway all the way up and see what, I have no idea what that does, but I'm gonna find out. Sway. I think it probably, I would imagine, yeah, it accentuates the roll itself, I think. So maybe I'm getting a little bit too much sway now on my roll. Let's see. When I'm, yeah, it's really trying to dump me out the side now. Wow. Yes, it's really made the, how much of the roll you're getting, the feel of it is increased. Go back the other way. Yeah, you can see how jerky that is. Yeah, that's way too much, obviously. Totally out of balance with what we want, but at least we know what it does now. So again, all we have to do is fine tune all this stuff. Go back down to half on that, and I'm going to go up on heave. I don't even know if I can, how the algorithms on this, the way the firmware has been tuned, what the heave is actually doing, but I will try to explain it as I'm going around here. Maybe. Yeah, it feels a little jerky, a little jerkier on the, yeah, on the, when you're going on the curbing and coming off the curbing. So when it comes down, snaps down and goes up, it feels like there's a little bit more motion there as far as the way it's pushing me. So let's go down here and see what happens. These are flats, so I shouldn't feel much there. Okay. All right, so yeah, I don't really, how about this curbing? Didn't do much on that one. So heave doesn't have an immediate effect like you, let's go on this curve. Nothing there. Not sure about the heave, if it's how much of effect that has here. All right, so there's not much else to do here as far as setting this up. Traction loss obviously doesn't matter. It shouldn't anyway, even though they may have something in the firmware here that tries to simulate that or emulate that. But yeah, pretty much that's all there is to it. And I just did this so you guys could see that you can move the sliders here, and it directly affects what's going on with the platform as far as how much it moves or how much it doesn't move, how fast it moves, and yeah, that kind of thing. Deceleration, acceleration on the surge. I had to figure that out. First I thought pitch would be braking and acceleration, but it's not. It's actually going up and down the hills, and that's why I have a hilly track here. I mean, you can really put that, as we did, we put that pitch up, man, it was really laying you back. So again, all this is going to be perfectly subjective, or totally subjective, as far as what you like or don't like about this. Now, I do feel a little bit of a jerkiness in the movements here, so I think less is more here, and it'll be less jerky. I think that I would like to see moving forward, DOFReality maybe develop some kind of a dampening or damping element to this platform. Maybe some springs or something, I don't know. But yeah, I think it would help out, because just your weight alone does dampen it a lot, but yeah, nothing like something that's always active as far as dampening. Right, so that's all for the test of what this software can do. I do like this software much better than SimTools. It's much easier to use, and I think it's going to open up more opportunity for people to use this than as soon as you find out you got to use SimTools for the DOFReality stuff. You kind of go, I don't know, man, because there is a learning curve there. Even though there's a lot of information out there, it still takes time to absorb it all and put it to use. Right, so enough of me rambling on. What we'll do next is, I don't know, I might shoot some video of me actually driving some other tracks with this. But yeah, so far so good with this, I think, for the money. I mean, we all got to remember what the price point of this is compared to the probably other solution that everybody's comparing this to, and that of course is the Next Level Racing V3 platform, which really is a different beast than this. And anyway, we'll talk more about that later on. But wait, there's more. All right, so I just wanted to add this at the very end of this, the review I was doing. I already had a lot of the video done. They sent me this application update from Sim Racing Studio. And what they've done is they've added some different things here. The motion test tab has the pitch, roll, and traction loss like they did before. But now they have a BWD for backwards and FWD for forward. Roll is now right and left, so it will let you determine if it's moving in the right direction. Before we just had pitch and roll, so we weren't sure if it was going to be moving in the right direction just by moving the slider up and down. I mean, it could have been left or right. So we also have that on the traction loss slider too. And that'll be used when we actually do the review on the H3 DOFReality platform. Now also, they've added games. So this is a whole new tab here. And this will actually tell you what games are ready to play. So which configurations have been loaded and installed so that you should be able to play the game. Kind of nice. Remember before over here in the motion tab, it was whatever you had going on down here as far as the games, right? But it didn't give us much detail on what was going on, just if that's the game we were going to be running. You can see when I went to iRacing, it changed back to the sliders that I had before because I saved it. So you can actually save, obviously, your setups for whatever game you're in and go back to emulator. You can see it leveled out to the defaults. And yeah, see whichever game you're in, you can save it and you can come back and do it again. So, right. So the games is pretty cool. If you click on, let's go down and click on iRacing and see what it does on the other side. So we'll click iRacing. All right, so I clicked iRacing, and it didn't change over there, though. So I guess what this means is, yeah, all it's doing is highlighting it. Okay, but I imagine eventually this is going to be, when you click on the game, it's going to load it from here. I don't know if they're going to continue having it over here or not, on the drop down over here on the motion tab or not. But anyway, just a quick update to let you guys see what the latest software is. So if you download it now, by the time you see this video review, then you will be seeing something like this. Okay, so what we'll do next is get to driving. All right, guys, I'm going to do a couple of quick segments here just to show that this seat does work in different games. Obviously, we're in iRacing now, which we actually spent a lot of time in when we were doing the segment on how the application controls the seat and the different controls and what effects they have. So we won't spend a lot of time in the actual driving of the seat in iRacing, but I just thought I'd show you another clip here. And this time we are over in Sebring in the 488 Ferrari. And yeah, once you have it dialed down a bit, I think that it's really where this seat shines. Less is more. I think I've said that before a couple of times, but yeah, less is definitely more. And here we are over in Assetto Corsa at the Corkscrew at Laguna Seca. And yeah, same thing here. Less is more. I may have had a little bit too much here in this shot. I'm not sure. I was sitting back watching it a minute ago. I was going, it looks like I'm moving a lot there. But yeah, I probably would have changed that later on as I was driving. But again, it works fine at Assetto Corsa. No problem setting it up and getting it to run, which is a big plus, obviously, because we want to be able to use this seat across multiple platforms. And here we are in Project Cars 2. So yeah, I didn't have a problem with that one either. And I thought, you know, use just these 3 games here is probably enough to prove that, yeah, as far as the Sim Racing Studios software or application is concerned, yeah, it's working well with the games that they have listed on there. Or I'm sure they wouldn't even be listed on there in the first place. Right. So what we'll do next is, yeah, we'll just go ahead and get to the final thoughts. Final thoughts on the M2 motion platform from the guys at DOFReality. The M2 is an entry-level motion platform from their series. It is designed to be an all-in-one motion solution that can be deployed in many different ways. There are 3 cockpits that it can be bolted to with no modifications: the Playseat, the Next Level Racing GT Ultimate, and the GT Omega ART. I didn't have one of those on hand, but was able to mount it to my SimLab P1 without too much effort. This platform is using 2 Sunrise motors, mounted to gearboxes featuring a worm gear configuration. There is a bit more gear lash in these units than I was expecting. The drive levers attached to the seat mount platform with a pair of rod ends that do allow a little bit of lateral play. Pivoting on a universal joint provides the 2 axes of movement. I found the movement of this platform to be a bit jerky at higher power levels, and even at lower power levels, the movement was not completely smooth. If DOFReality would add a hardware dampening solution to this unit, I think it would allow it to go to the next level of performance. Of course, if you did this, it would add cost to the M2, but something I think most would not mind paying to smooth out these movements. At $899, it's already the least expensive seat mover solution I could find that is available from a retail vendor. What's really great here is that DOFReality and SimRacing Studio have teamed up, so you can now use the SRS application to control the M2, along with the H2, the H3, and P3 platforms. This has shortened the learning curve when using sim tools to control these platforms by quite a lot. If you already have a fan or shaker solution from SimRacing Studio, using their app to control the M2 is a breeze. I did use the M2 mostly in iRacing for the tuning process segments of this review, but it also worked in Assetto Corsa and Project Cars 2 without any issues. Overall, I would say the M2 motion platform is not something for the person who wants the most refined seat moving solution available, but for the individual who is budget-minded and doesn't mind a less than smooth ride when racing, and likes to spend time tweaking settings to wring out the best they can from the M2 in its current configuration. I'm Barry Rowland. Thanks again for watching the SimRacing Garage. Don't forget to hit the subscribe button, and if you would like to help support what I do here at the SRG, visit my website at simracinggarage.com.